Hello, I'm Mingchen. Welcome to our work. The title of our work is EnergyAction, Unmanual to Bimanual Composition with Energy-Based Model. First, let me briefly introduce energy-based models, or EBMs. The core idea is that lower energy means higher probability and better compatibility, while higher energy means lower probability and weaker compatibility. Different from a feed-forward model that directly predicts an output, an EBM evaluates the compatibility between the input and a candidate output. Since the energy is a scalar value, it can be flexibly used for optimization, selection, composition, and inference. This property is important for our method because it allows different policies and constraints to be integrated in a unified energy form. A key characteristic of EBMs is compositionality. For example, in image generation, different visual concepts can be modeled as separate energy functions. Then we can combine these functions through simple operations, such as addition or subtraction, to generate images satisfying multiple conditions. From the probability view, combining two conditions corresponds to multiplying two distributions. In the energy form, this becomes adding two energy functions. This gives us a principled way to compose different concepts, priors, or constraints. Inspired by this compositional property, we apply EBMs to robotic manipulation. Our motivation is that unmanual models and datasets are abundant, but bimanual data is much more limited. So the key question is, how can we transfer from unmanual manipulation to bimanual manipulation? Our idea is to regard the left arm action and the right arm action as outputs from two generative models. Instead of simply concatenating them, we compose them through an energy-based framework to generate a coordinated and synchronized bimanual action. Our method has three main components. First, we model pretrained left arm and right arm policies as energy functions, where each function evaluates whether a single arm action is reasonable under the current instruction, observation, and robot state. Second, we introduce energy-based temporal spatial coordination. Temporal constraints encourage smoothness and left-right synchronization, while spatial constraints improve collision avoidance and joint space feasibility. Third, we propose an energy-aware denoising strategy. During inference, we adjust the denoising process according to the current energy value. If the action already has low energy, we stop early, otherwise, we continue refinement. This improves both action quality and inference efficiency. We evaluate energy action on several bimanual manipulation tasks in our REL Bench 2. The comparison results show that our method achieves strong performance under different demonstration settings. Especially when only a small number of bimanual demonstrations are available, energy action still performs well. This indicates that energy-based composition can effectively reuse knowledge from pretrained unmanual policies and transfer it to bimanual tasks in a data-efficient way. We also conduct ablation studies to analyze the contribution of each component. The results show that removing energy composition, temporal constraints, or spatial constraints all decreases the success rate, which means that each component is important. The scaling result further shows that when more single-arm pretraining tasks are used, the performance of energy action continues to improve. In addition, the denoising step distribution shows that our energy-aware inference strategy can often use fewer denoising steps while maintaining a high success rate. To conclude, we propose energy action, an energy-based framework for transferring pretrained unmanual policies to bimanual tasks. First, we represent left arm and right arm policies as composable energy functions. Second, we introduce temporal spatial energy constraints to improve synchronization, smoothness, collision avoidance, and feasibility. Third, we design energy-aware denoising strategies to reduce unnecessary computation during inference. Overall, energy action provides an effective and data-efficient way to compose unmanual policies into bimanual manipulation skills. That concludes my presentation. Thank you for your attention.